Class. So, yeah, go for it. It's right there. What we need to do, we've already got the graph. We put the error bars on there. I showed you my secret way to do that. And what we need to do is we need to find the slope of this, right? The slope of a force versus distance graph for a spring is going to be its spring constant. Does that make sense? Because it's F equals Kx. X is literally the x-axis, F is the y-axis, so K is therefore the slope. Yes, isn't it? Yeah? And this graph should have a 0 y-intercept. It should just be F equals Kx plus 0, right? And then the other thing we can do is we can also find the uncertainty of our slope, okay? And so that's what I'm going to do. I'm going to show you how to do that, and Michael is going to be so nice as to hand out those to everybody. You want to do that? I'll do some over here. 1, 2, 3, 4, 5.
Thank you.
Very cool shirt.
1, 2, 3, 4, 5.
Thank you, Mom.
All righty. So the first thing to do is to draw our best fit line, and keep in mind that the best fit line does not connect the first and last points necessarily. It's, in your judgment, the best line, the line that comes the closest to all the points. Okay? And I'm going to choose this as my best fit line. There we go. And how do we find the slopes of lines? Well, I can't use, to find the slope of this line, I can't use any of the points in the data table from which the graph came. Okay? And they're going to look for that. They're going to say find the slope of the line, and they're going to look for you to use the first and last points. Definitely don't do that. Okay? So how do we find the slope of a line? Do we read like 2 points as far away as possible? Right? And I'm just going to go out to point 3. Right? Do we read this graph at these points there and there? Yeah? And then just find the slope? Right? Now, as luck would have it, my thing goes right through the origin there. And so the rise and the run are really pretty simple here. So I just have to read it off the graph. So the best fit line, slope is the rise, and the rise looks to be 9.2, I think, for me. And the run is 0.3. 0.300 or something like that, right? I don't think we really have all that many sig figs because we're reading off the graph. And then I can calculate that. 9.2 divided by 0.3, 30.667. So I'll say 30.67. And this is newtons of force, meters of length, so that's newtons per meter. Clearly that's a spring constant. Yeah? Now how do we find the steepest slope that is possible? Well, I was taught, this is what I was taught in college, was that we had to keep the line inside all of the error bars and make it as steep as possible, which makes it about like this. Yeah? IB wants us to, unless the first or last point is an outlier, and we could argue that this point seems to be kind of an outlier, but I don't think you can say that it's necessarily an outlier. Right? It could just be error. In other words, this guy looks like he's high for the rest of the points, doesn't it? Right? But what IB wants you to do is use exactly the first and last points, error bars. So the bottom of this error bar, top of that error bar, yeah? There's the steepest line that we can do. And here's the least steep line that we can do. Yeah? Yeah? Now, in college, I would have been dinged because this steepest line actually misses the top of that error bar, right? So, you know, and I don't know what to do. IB wants you to do this. This is, by the way, the only thing you can do to completely satisfy this criteria, right? Even those myriad of beautiful data analyses we could do, this is the only thing that they have chosen to be the thing that fulfills, which is both good and bad, by the way. It's bad because I don't think it's terribly valid. It's good because it's pretty much the only thing I really have to show you. And you can get it complete, right? Okay. Now, if we are using the first and last points and the extent of their error bar, can't we just cheat and read the numbers off of this data table to find the slope? Can't we? I think we can, don't you? Yeah, I think we can do it, right? So in other words, the steepest line is going to have the biggest rise. So it's going to rise as high as possible. So it's going to be 9.9, right? This number plus 0.5, right? So 9.4 plus 0.5, right? 9.9 minus the lowest number possible, right? So 1.6 minus 0.5 is 1.1, right? And then the run, I'm just going to say, is we don't even need to read the graph to do that. Isn't that right? Do you see how that's going to be the steepest? Highest high point minus the lowest low point. Do you see that 9.9 is 9.4 plus 0.5? 1.1 is 1.6 minus 0.5. That's how I'm getting those. Are we good on that? Right? So I can find that without really reading my graph. 9.9 minus 1.1 divided by 0.3 minus 0.05. I get 35.20. Okay. And I suppose that would be good to show it on your graph. I'd put it on here because that's simple. But you could show that calculation on the graph. What would be the least steep? Isn't this point right here 8.9 and this point here 2.1? Looking at the data. Right? In other words, we make this guy high, this guy low. Isn't that going to give us the least steep one? What's the antonym of steepest? Shallowest? Least steep? It doesn't have an antonym, does it? Flattest. Should we say flattest? That doesn't work either so well. Looking for an antonym to steepest.
Shallow?
I know, yeah. Shallow? Least steep? I don't know. I'm going to say least steep because I believe that. Yeah, we do. Does it have antonyms? Okay, the least steep is going to be 9.4 minus 0.5, so that's going to be 8.9 minus 1.6 plus, right? So that's going to be 2.1. That's the least amount of rise we could have. The run we're not going to change. So 8.9 minus 2.1 parentheses, right? Divided by 0.3 minus 0.05. 27.20. So now we've got to label this, right? Steepest line. Show your calculation. If you can show it on the graph, that's just fine. Steepest line has a slope of 35.20 newtons per meter. Shallowest line. I'll go with shallow. Is